This is example 1216. We're given this track which has a constant radius, so we could have done either normal tangential, but it does say that the tangential acceleration is 0.2 t meters per second squared, so this means that we should really do this problem in normal tangential coordinates. So they want us to find the magnitude of the acceleration at point B. We're given that this tangential acceleration is 0.2 times t meters per second squared and is traveling along the track as shown. We're also given that it starts from rest at point A, so that means v at A equals 0. Okay, so let's see. The acceleration in normal coordinates is the tangential acceleration times the tangential unit vector plus v squared over r, or rho, in the normal direction. And so let's highlight in green again the things we know. We know that we don't know the velocity at point B, but we know the radius. So let's go from there. Okay, so let's see if we can figure out the velocity. So we know that the tangential acceleration, which is v dot, is 0.2 t. So to get the velocity, dv equals 0.2 t dt, because v is just dv dt. And so for the integral from 0 to v, 0 because it starts at rest, dv equals the integral from 0 to t, 0.2 t dt. That's a pretty easy integral. So we know that velocity equals 0.1 t squared. Unfortunately, we don't know the time it takes to get to point B. But we do know that it has to travel 3 meters on the straightaway and then a quarter of the circle. So we know the distance. So we're going to use v equals ds dt, or ds equals v dt, which is 0.1 t squared dt. And so now we can integrate that. So the integral from 0 to point B, we'll figure that out in a little bit, ds equals integral from 0 to t, which is unknown, 0.1 t squared dt. So that integral's pretty easy. It's 0.1 over 3 t cubed from 0 to t, which is 0.1 over 3 t cubed. Okay, and so we have 0 to s at point B equals 0.1 over 3t squared. So what we need to do is figure out how long this is. So that's 3 meters. The radius was 2 meters, so we need to figure out this distance. So I figured out that the length of a quarter circle with radius of 2 is 3.142 meters. So the total length traveled is 6.142 meters, and that's going to equal 0.1 over 3t squared. So the time it takes to get to point B is 5.69 seconds. So now that we know that, we can get v, because we know that v is 0.1 t squared. So if you plug in 5.69 into that, you get 3.238 meters per second. And now that we know v, we can get the final acceleration. So here's the acceleration again. So we know that at, that was given as 0.2 t. And t was 5.69 seconds. So 0.2 times 5.69. And that comes out to let's see, 1.138 meters per second squared. V squared over rho. So we knew that the velocity is 3.238 squared. The radius was 2. And so that comes out to 5.242 meters per second squared. And so finally, the acceleration is, the total acceleration is 1.138 squared, square root, and that comes out to 5.36 meters per second squared. And I guess if you wanted to draw the vector, it would be 1.138, oops, yep, that way, and 5.242 that way. Okay, that's it.